So in today's lesson, I want to begin our conversation about chemical bonding. And so we've taken a deep dive into Bohr-Rutherford diagrams and analyzed how they can help us predict the number of valence electrons that we see in an atom. But we're kind of at the point where we're ready to leave those behind and look at a more simplistic way of representing those valence electrons. And here comes in electron dot diagrams. So from now on, what we're going to be using, and in particular as we start to navigate Lewis dot structures, is these electron dot diagrams. They're going to become prominent. So what is an electron dot diagram? Essentially what it is, it's a diagram with the element symbol in it and a dot representing the number of valence electrons. So if I were to look on the periodic table, I would see that lithium is in group 1. And so with 1 being group 1, lithium and all of the elements below it are going to have a single valence electron. And so we can kind of continue that trend looking, and so I've selected elements moving across a period on the periodic table. And so we know that as we move across the periodic table in a period, we're simply adding a valence electron as we go across. So beryllium, as a result, would have 2 valence electrons. And so it's really important that we kind of go around the world here. We're not going to pair up any 2 valence electrons until we make sure that we have 1 in each sort of quadrant, if you will. Right? So boron having 3 valence electrons, and then suddenly carbon here with 4. And you may be asking, well, does it matter where you start? No, it doesn't matter where you start. So for instance, I might start nitrogen up here with 1 valence electron, 2, 3, 4, and then 5, and now I have a pair, right? And so on and on and on. So oxygen has 6 valence electrons, and I think you're seeing the trend here. So I'm just going to kind of carry on here. Fluorine, being a halogen, is going to have 7 valence electrons. And then finally, neon, being our noble glass, let me make that a little prettier, with 8 valence electrons. And so after a while, you won't have to worry about, going around the world if you know the number of valence electrons, because you'll know how many pairs of electrons you'll have and how many lone electrons you'll have. So there we go. So pretty simplistic, I think, just a lot easier. We're really only concerned with those valence electrons, as they are the electrons involved in bonding. Those inner electrons are not typically involved in bonding, so we can kind of put them to the side and ignore them to a certain degree. All right, so a couple more notes that I want to talk about here. So I want to remind you about the octet rule. So octet, oct meaning 8, and so we're talking about an electron being, an atom rather, being stable when it has a full valence shell. And for most of our atoms that we're going to consider in this course, that's going to mean 8 electrons in the valence shell. Let me get that a little nicer here. 8 electrons in its valence shell. Needing to, of course, remember that we have some exceptions here. So hydrogen, remembering in that first energy level, the atoms are satisfied, are stable with 2 valence electrons. So hydrogen, of course, is going to be stable with its 1 electron, but it can also, it leaves room to have another electron there, but only 1 more. Helium, in that first shell there, we know it's a noble gas, so it has 2 valence electrons that it's perfectly stable with. It doesn't need 8. And then, of course, once we look at lithium with an atomic number of 3, it has 3 electrons, so that first energy level is filled up with 2, and then we move on to the next level. Right, so we need to know that, atoms are stable when their outer shell is full. So for most atoms, that's going to mean 8 electrons, but hydrogen and helium, they're going to be okay with just 2 electrons. So I hope that's a decent refresher for you, and that most of those ideas were familiar and that we've just reinforced them. But be sure to reach out if you have any questions or you need some clarification.